Hi, so this is the second test flight of the levitation vehicle, and I'm just starting off to document the initial settings which I start out with today here. So I'm just going to scroll through those values. During the film here I'm going to run the batteries from 4.2 volt per cell down to 3.8 volt per cell. So it's pretty much as much capacity that you would like to extract from the batteries. I think there's perhaps like 10% more you could extract without damaging the cells to go down to 3.7 volts, but I stopped at 3.78 or so, or 3.8 volts per cell. And I'm not sure the exact flight time, I haven't clocked it, but I think it's around 25 minutes or so. And my overall goal here today is to try to adjust the settings in the flight controller so that I get a more connected feeling to the craft, so I feel more confident to actually start moving the craft around, not just hovering it. And it turned out that it was actually possible to get a more connected feeling. Although the craft is so docile, it's still more connected to the controller than it was in the previous first test flight session. So another change that I did is that I added sort of the cardboard flag to the craft, so that I have easier to keep the orientation, so that I know in which direction the flight controller is pointing. So the flag is at the back of the flight controller, so to speak. So I'm flying forward now, and then I'm going in reverse when I'm flying towards myself. Another mechanical adjustment or flight controller adjustment is that I have previous flight I had the throttle slightly linked to the control surfaces, so that when I increased the throttle I also increased lift on the rotating wings via the flight surfaces. They were like pointing slightly downwards, and when I reduced the throttle they were going up to command like lower lift on the wing. I thought that would help me to have like a better authority over the vertical movement of the aircraft, but it didn't help me keep it stable in flight. It somehow got like oversensitive, because it's very sensitive to RPM change in the motors. I mean, it's lagging, but it's a very distinct coupling, of course. So in this whole flight session I have the vertical control is only by increasing throttle, and that feels better. So there's a lot of, I mean, this is a tuning flight session, so there's a lot of time spending pondering whether I should go up or down in a certain value, or it's a lot of reflecting, and I cut away most of that. So now I'm trying just to set a slightly higher stick scaling. So I went down super low to a value of 8, and 100 is like 100%, so you are like overriding almost the flight controller. But 8 was a little bit too low. I had a hard time actually getting the craft back. Although this is pretty much dead calm weather, it still was difficult to have a positive like authority over where the craft was going. So I'm increasing the value here. And I don't know if it was like totally clear in the previous video. I was sort of up in a like arousing feeling, because it was so amazing just to see it fly. But the control surfaces on the wings has a very significant influence on how much lift the wings generate. So if the control surfaces are flush, just following the wings direction, I have a lift value of say 5, and when I have them maximum up deflected, so that I reduce thrust, I can come down to under a value of 2, and when I have them fully fold down, almost like a flap on an airplane, it's almost a 90-degree bend, I can have a lift value of around 8. So each wing can produce from 2 to 8 in lift, and that's mostly used to just keep it stable and for the flight controller to use to control the craft. From time to time you can see that the craft seems to get bumped around, and that is because I'm intentionally trying just to bump the sticks and see how fast it self-levels again. So I'm just figuring out if the P and I settings in the flight controller are adequate. It's kind of hard to say on this big slow moving machines. I'm not used to what kind of response would be like adequate. In a small machine you can see like oscillations. It's easy to see oscillations in a small machine, in a small multi-rotor, but in this big spinning thing I don't really know what oscillation would look like. It might not even be easily detectable. It might more be that you get excessive heat in the servos that controls the control surfaces, rather than you can see that the craft starts to oscillate. But it's still a bad thing if you have like too high settings. In this session I flew so long so that I actually got to the point that I was kind of relaxed, and I was able to start just enjoying and see the actual craft spinning in the air. Previously I have had fixed points on the craft that I had been focusing on to see whether or not the craft was tilting or going like away or towards me, because ironically, although the craft is so big, it's actually harder to see if it's coming or going, so to speak. You would have to stand further away to see that. When you're close, it's difficult to judge whether or not it's starting to drift. So I had like fixed points to look at, but now when I feel more relaxed I can just watch it spin, and it's really hypnotic and mesmerizing. You can almost see the airflow over the wings. It's you can hear the swashing. It's a buzzing sound from the motor, especially from one motor. I don't know why there's like a angry bee sound from one of the wings. You can hear it come and go around 1 hertz, but you can also hear a swashing sound, and it's soothing, very soothing for your like soul, your aviation soul. And it's even more like impressive when you think about that. It's actually carrying around 11.5 or 12 kilograms, like 25 pounds into the air with this slow moving rotor. It's just amazing to see it in action, and it really looks quite similar on film as well. But when I'm looking at it now, I'm at a little bit further distance, and it almost makes it even better. One thing that I really appreciate with this project that's not existing in the smaller over-terrain vehicle series of projects is that the flight aesthetics is back. This is like more of a sailplane aesthetic feeling. The coupling to the air is more obvious here. It's not as binary or digital as it is in a conventional multi-rotor. So I really appreciate the feeling of that I'm out and just playing with the surroundings and the air. And this is one of my favorite situations in life. It's a late evening. I think it's like 8:30 here in like the middle part of Sweden. So it's quite bright still, and it's around like 19 centigrades outside, and it's absolutely dead calm. And I'm out there in the forest, in the woods, and just exploring technical stuff, aeronautic stuff, and I'm feeling the like sensation of the smells of the forest and the flowers and everything, the surroundings, and it's it's like my life elixir to have these moments. One thing that I noticed when I started to move the craft a little bit more laterally, moving like forward and sideways, is that kind of movements have a really big impact on the power consumption. So it's so obvious that you're spending energy to start accelerating the craft sideways. So you have to compensate a lot with the propulsion motors to not just have the craft sinking down. And of course, this machine is obviously intended for these kind of conditions when it is pretty much dead still, because the symmetry of lift of this slow rotating device is of course very significant. So if you're like going fast forward, or I mean you can't go fast forward because the retreating wing would be like in still air. So you can obviously just move very slowly, and it wouldn't take a lot of wind to like neutralize the lift on one side of the craft. The control surfaces again can produce a significant difference in lift, but it can only compensate for so much headwind. So this is all about the being up in the air experience, and just like a different perspective, and enjoying a calm morning or a calm evening. So it's really not a transportation device in any sense. It's just about like giving you the feeling of flight and the excitement around that, and also being out in the nature in this beautiful time of the year. Okay, so I'm gonna leave you with that, and I'm gonna let the full rest of the flight up here, both for for anyone to enjoy and for me to remember as well, and perhaps go back to recheck how it flew during various settings. In the end of the clip, I'm just going to scroll through the flight controller again to see how I've changed the values. So to sum it up, I did increase the gains significantly, and I don't know if that's the best settings yet, but I will of course be doing more testing as soon as I get the chance, weather-wise and in life, to continue exploring settings to make it feel even more connected to the transmitter, and and explore just the various aspects of this machine. There are many tests that I would like to conduct, but I will get back with that. So until then, take care, and I'll see you later. ökar jag I-gain på pitch och roll från 80 till 100 och P-gain är fortfarande 200. Ja, marken lutar hit och dit, så det är inte lätt. Jag testar att dra upp P och I-gain från 200 till 250. Ja, det kändes bättre med 250. Så fortfarande 250 i PI gain och 250 i pitch och roll och sen så 100 i I gain. Från 15 till 20 på stick scaling, pitch och roll. Nej, kändes inte helt mycket bättre. Nej. Bättre. Ja, men det kändes bra bortsett från att den började dra mer och mer. Bortåt kände jag, så jag är tvungen att hålla mer och mer bakroder. Jag ska se om jag kan levla den bättre och om jag kan... Jag ska öka upp stick scalingen igen till 20 då. Jag hade testat P-gain, pitch och roll 300 från 270. 3.78 volts or so per cell. The hottest part by far is this motor here, although this battery that powers that is still at like 4.02 volts per cell, so there's a lot of extra energy for doing this thing, but this is so inefficient. It's hot. The next hottest thing are the servos. So they are sort of they don't have any airflow, they're totally encapsulated there, so it's a lot of flying ants right now. And the motors are not even lukewarm, they're under body temperature, and it's like 23 degrees Celsius outside, and they can't be more than, I don't know, 20, I don't know, they're not actually, I can't feel any heat at all, so they're well, they have super good cooling, of course, being out here in the airstream, but anyway, they could do a lot more work without taking any damage. I mean, they're probably just at half power or what their maximum sustainable power is or so. I ended up with quite different settings from what I set out with today. So I started out with 160 in pitch and roll gain, P gain. I'm up to 300 now, and the I gain was at 80, and now it's 100. So yeah, it seems to handle significantly more gain well. And the roll went also, the rudder went up a little bit as well. The yaw gain from 80 to 100 there, both P and I. Let's see here. Oh, sorry. Oops. And I also, stick scaling went from 30 down to 8 and 10 and 12, 15, and then went up to 20 again. It seems to be adequate. If you have too much, it gets, since the wings are turning so slow, and if you have a significant impact with the stick when you're flying it, it will more like kick up rather than tilt gently. It will get like, I don't know, it's not a even like disc that starts to tilt. It's more like a wonky movement, and it seems to just disturb the whole system. So it's actually better, I think, to have a little bit less of an influence on the flight controller rather than having like a firm grip, because it doesn't feel like you have a firm grip if you increase these values. Counterintuitive, as so often with physics and flight dynamics. And other than that, I did in the let's say mixer editor. Before this is like the first sector, that's the front sector. Before I had every sector coupled to the throttle, which means that the throttle was slightly coupled to the rudders here, so that I had like more deflection, more lift when I went up in power, and less lift when I went down in power, because I thought I needed more reactive like vertical movement, but that didn't feel right, so I turned it down to 0. So now I only control height with the speed of the motors, and then the speed of the propellers, of course, and that seems to work pretty good. I mean, it's sort of lagging, but it's a logical feeling in the lag.